I'm going to walk through a series of cartoons that help you understand the relationship of these temperature sensors and skin sensors in the left wing. These are not engineering drawings by any stretch of the imagination. I also want to caution you that the times that are identified on these particular slides are very preliminary. In fact, I am not confident that these are the right times at all. One of the reasons why you're not seeing the timeline today is because we don't believe we have the right times established. This was our first burst of data. This was our first run through the information, and we anchored on some of these time frames. Now, as we are going through and poring over the data in more detail, we're finding that we made some mistakes in identifying where the right points should be. And I've asked the team to go back and review that again because I do not want to put out any misinformation on the timeline. So even though these times show up in these charts, I want you to understand they're going to change. So when I read the newspaper tomorrow, I hope you put some caveats to say these aren't the solid numbers, because they aren't. They are going to change. Let's go to the next chart. Okay, let me explain to you how to read the chart. You're looking at a top view of the wing. It's the left wing. We've tried to identify the sensors that we have talked about over the last week. You can see the wheel well. There are a number of sensors located in there. And at this point, at the beginning of the time frame that we have studied, which is about 7:52 a.m. Central Standard Time, GMT, it's 13:52 to get that correlation. Everything in green is a good sensor functioning nominally. An off-nominal sensor is going to show up as red, and then a sensor that just quits working, as we have talked about, it goes off scale low or off scale high, is going to show up as black as we step through this sequence. So here we are at 13:52 or 7:52 a.m. in the morning Central Standard Time, approximately 7 minutes prior to the loss of signal, where we lost communication and data from the vehicle and the crew. Let's go to the next slide. Here we are 20 seconds later, and again, caution you about the times and the delta time frames. These are all going to change. I want you to understand the relationship of these sensors, not necessarily the times, but it gives you a feel of what we're trying to review and what we're trying to investigate. The first indication, left main gear brake line temperature starts to rise. A 2 degree per minute rise is not significant. So we are not sure whether this is a real start of any significant event, but we're pointing that out today. First indication, as it shows red on the view graph. Next chart. Left main gear brake line temperature A starts to rise. I should point out also, as you look at the chart, I don't know if you can see that well, but there is kind of an orange or yellow cabling that connects several of the green sensors from the wheel well down into the back part of the wing or the trailing edge of the wing. The way to think about that is it's all in one common wire bundle or a set of bundles. There's a blue bundle or wire bundle at the trailing edge of the wing. That's a separate wire bundle. So that's going to become important to us as we think about common points of where there could be some heat source that could, at one location, disrupt several sensors. Let's go to the next chart. This is the third indication. The left main gear brake line temperature C starts to rise again in the wheel well. The next chart. First indication of a skin temperature going offline. You can see it's on the left inboard elevon. This is one that just quits working. Next chart. Hydraulic system 3, left outboard elevon actuator return line temperature, goes offline, stops working, stops registering as functional. Next chart. Hydraulic system 1, left inboard elevon actuator return line temperature becomes non-functional. Next chart. Hydraulic system 1, left outboard elevon actuator return line temperature, again, non-functional. Hydraulic system 2, left inboard elevon actuator return line temp, again, non-functional. So you can see we're trying to develop an understanding of a pattern and whether or not there is some common point that is preventing these sensors from functioning. And we're looking certainly at the wiring and the routing of the cables and the timeline. If you looked at the top of the chart, you can see that we're just running along the timeline in a sequence of events. Next chart's the left main gear brake line temperature B. We start to see it rise, so now we're back into the wheel well again. The next chart, mid-fuselage left body line temperature. Now this one's interesting because we don't believe it's connected in any of the wire bundles to what's in the elevon or what's in the wheel well. And so it's odd to us that this appears suddenly, but it begins to rise. And again, this is on the sidewall of the orbiter, back in this location. Not on the wing, on the sidewall. Whether that's important or not, we don't know. And so that's part of the investigation. Next chart, left main gear strut actuator temperature begins to rise. Next chart, left main gear uplock actuator unlock line temperature begins to rise. Okay, here we are at approximately 7:54 a.m. Central Standard Time. No reports from the crew, no reports from our flight control teams. Everything is operating and functioning nominally in all of our systems. All we are seeing is some of these sensors dropping offline in a sequence of events over a period of time. Next chart, system 3, left hand, forward brake, switch valve, return line temperature starts to rise, back in the wheel well. Next, main landing gear, left outboard wheel temperature goes offline. Remember I explained to you previously that we had sensors on both of the tires in the wheel well. In a sequence of time, you'll see that they all didn't go offline or quit functioning at the same time, which leads us to believe that we didn't lose the tire. The tire didn't deflate. We didn't have some event happening, but what it means we don't know yet. Let's go to the next chart. Left upper wing skin temperature, left lower wing skin temperature goes offline. So you can see it's connected to the cabling that is common to many other sensors. Next chart, system 2, left hand. Aft brake switch valve return temperature starts an off nominal temperature rise. And when I say start, again, I'll go back to what I mentioned previously in this briefing, and that is we're not sure where these start times really mean anything to us. This may be such a gradual change at the start times I'm talking about that it is not an off nominal event. As we go back and examine the data, we may find that it was relatively flat in this time frame, and then 2 or 3 minutes later, it took a significant swing upward in temperature. And that's why I say I'm not sure we have the right starting point, but I hope you're getting the idea of what we're trying to look at. Next chart's the main landing gear left hand outboard tire pressure. Number 1 goes offline, non-functional. Next chart, main landing gear left hand inboard tire pressure goes offline. So you can see the sequence of how these things are starting to add up. Here we are at 7:58 approximately. a.m., and so we're getting near to the time where we lost contact with the crew in the vehicle. Next chart's the main landing gear left-hand inboard wheel temperature goes offline. Next chart, main landing gear left-hand outboard tire pressure goes offline. Next chart, main landing gear left-hand inboard tire pressure, number 2, stops working. I believe that's the last chart. So that's the sequence of events as far as all the data that I've tried to explain to you over the last week. One of the reasons why you're not seeing the timeline today is because we don't believe we have the right times established. This was our first burst of data. This was our first run through the information, and we anchored on some of these time frames. Now, as we are going through a stretch of the imagination, I also want to caution you that the times that are identified on these particular slides are very preliminary. In fact, I am not confident that these are the right times at all. We're poring over the data in more detail. We're finding that we made some mistakes in identifying where the right points should be. And I've asked the team to go back and review that again because I do not want to put out any misinformation on the timeline. So even I'm going to walk through a series of cartoons that help you understand the relationship of these temperature sensors and skin sensors in the left wing. These are not engineering drawings by any, though these times show up in these charts. I want you to understand they're going to change. So when I read the newspaper tomorrow, I hope you put some caveats to say these aren't the solid numbers, because they